To create twin the power of k designs in R, we are going to use the FRF2 package, which is a package to build and to analyze fractional designs. Let's start by loading it. We can use several different parameters to build fractional designs using the FRF2 function. In this tutorial, we are going to see how to use some basic ones, as the number of factors, the number of treatments, and the design resolution. Let's start by building the fractional design of the previous video, the 2 in the power of 5 minus 2, using as arguments the number of factors and the number of runs. It will return the design with the highest possible resolution. We are creating the design DSG by using the FRF2 function. The arguments are the number of factors, 5, and the number of runs, 8. To view the design, we are going to use the summary function. Let's run it. The output shows that the design has 8 runs, as we have set. The other important piece of information is the design generators. In this design, D is equal to AB and E is equal to AC. The identities of this design are ABD, ACE, and the combination between them, BCDE. So this is a resolution 3 design, where the main factors are alias to two-factor interactions, and the two-factor interactions are alias to each other. The alias structure shows exactly this. The main factor A is alias to BD and CE, the main factor B with AD, C with AE, D with AB, and E with AC, and the two-factor interactions BC with DE and BE with CD. And finally, we have the design itself, the combination of the low and high levels of the 5 factors A, B, C, D, and E. However, let's imagine we are not happy with having a resolution 3 design, as the alias between main factors and two-factor interactions can hinder the analysis. For this reason, we would like to have at least a resolution 4 design. In our next design, we are going to use the number of factors and the design resolution as parameters. It will result in the smallest possible fractional design. So here we have the design DSG with the FRF2 function, and the arguments are the number of factors 5 and the design resolution 4. Let's run it. The output shows that we need at least 16 runs for the resolution 4 design. And we have only one design generator, E equal to ABCD. This tells us two things. First, this is a half fraction design, and second, this is a resolution 5 design, since the design identity ABCDE has 5 letters. The alias structure shows that there is no aliasing among main effect and two-factor interactions, as it is expected for a resolution 5 design. And finally, we can see the design itself. The 16 runs are the combination of the low and high levels of factors A, B, C, D, and E. However, how can you use this design outside R? To view the design as a table, we can use the view function. And here we have the design now shown as a table and not in the console. To export the design, we can use the write_csv function, but first we need to set where we are going to save it. To do it, we are going to click in the tab Files and select the folder where we would like to save. I have mine already selected. Then we are going to click in the little gear in this right side and set as working directory. The arguments of the write_csv function are the object we are going to save, in this case DSG, and the name of the file. So let's run it. Now we can see the design saved as a CSV file. We can use Microsoft Excel, macOS Numbers, Google Sheets, or any other software to open, edit, and write over it. In our next lesson, we are going to look at how to solve a highly fractionated design. Take care and see you shortly.